Hello, ladies and gentlemen. Welcome back to Excel Island and welcome to day 6 of 100 days of Power BI. The goal and objective is to learn and master Power BI over the next 100 days and build quite a lot of portfolios and use data sets online to practice and hone our Power BI skills. I'm super excited. Today is day 6. We have a lot to cover. So without further ado, let's get back to learning. Also, all the data set exercise files so you can follow along with me will be linked under the YouTube description. If you've missed previous live stream, the first 5 days, I encourage you to catch up by watching the previous live stream on the channel so you can catch up with the lessons taught in those live stream because we will be using it along the journey. So without further ado, let's get back to lesson. So basically, I'm currently subscribed to a 1-year subscription on the DataCamp platform. So I'll be using that. I'm using the DataCamp platform to hone my skills in Power BI. So if I go back to the progress dashboard on DataCamp platform, we're actually on introduction to DAX in Power BI. So that's the lesson we are currently taking. So if I go under the career tracks on the DataCamp platform, so we've covered data analysis in SQLs from previous live stream. That was my first ever live streaming journey on the channel. So we did data analysis in SQL over a 100-day period, and we were able to where it was successful and we were able to complete it. So I've learned a lot from that experience, and that's why this live stream is going smoothly and smoothly and smoothly. So now we're moving to the data analysis in Power BI. You can see we are 7% through the whole learning, through the whole lessons. And this data analysis in Power BI actually contains 17 courses estimated to be completed in 48 hours. I know definitely you're going to spend more than that while practicing and learning with the instructors. So we've covered introduction to Power BI in the first 4 days. So you can catch up. So we started the introduction to DAX in Power BI on the 5th day. So today is the 6th day. So let us continue. So you can see continue course. We've actually completed in this introduction to DAX, it actually contains three courses. So we completed the one getting started with DAX on day 5. So do make sure to watch that and complete that also, because the knowledge, the lessons there are very important in moving on to the next lesson, on to the next lesson, to the next lesson. So welcome to content in DAX formulas. You can see. So let's complete this part also on this live stream. So if you are completing one course in each chapter per live stream, we should be able to complete that, the whole courses within the next 100 days, even less than 100 days, and use the many days to build quite a lot of portfolios and build Power BI report and dashboard. So before I continue, I'd love to download the slide for this chapter too. Do not forget the data sets, all the exercise files, data sets is linked below under the description. Just click on the link under that to download the files so you can practice along with me. So I'll just download this real quick. Content in DAX formula. This is it here. Download. That has been downloaded. So I'll open that in my other screen. Yep. So I actually have two screens connected to my laptop. So making everything smooth and easy. Okay, I'll get my headsets on. Yep. All right, let's continue learning.
Welcome back. In this chapter, we'll take a
Hold up. Let me switch my speaker to headphone. Yeah.
look at context in Power BI. In this chapter, we'll take a closer look at context in Power BI. We'll also dive deeper into DAX formulas and understand the use of variables and the calculate function. Context is an important concept to understand in DAX. It enables dynamic analysis where the results of a formula change to reflect the selected data. There are three types of context: row, filter, and query. In this chapter, we will cover row and filter context, which are key to becoming a DAX master. Query context falls outside of the scope of this course. You can learn more about query context in future DAX courses. Row context can be thought of as the current row. A calculated column is an example of where row context applies. In a calculated column, the context includes the values from all columns within the current row. In the table below, we have a calculated column, price with tax, which contains a formula that does a calculation on the price and tax column. As you can see, the calculation is happening row by row, a perfect example of row context in action. Row context can also be used in measures, however, only when using iterator functions. An iterator function loops through every row in a table and runs the formula for each row. An iterator function can be identified by an X at the end of a function name. For example, SUMX takes two arguments: the table that needs to be iterated over and the calculation that needs to happen, similar to what we'd use in a calculated column. For example, if we wanted to get the output of our price with tax column without ever creating a calculated column, we could use SUMX to iterate over each row and perform the calculation. This would give us a total value of $70. Filter context is a set of filters that have been applied before the calculation is carried out. They can be applied in several ways, including attributes in a row or column, via a slider, through the filter pane, or in a calculated measure. In this example, we have a table of data and we'd like to apply a filter of blue. In order for Power BI to return a value for the color blue, it will go to the base table and apply a filter where color is equal to blue. This is filter context. It is applying the filter context on each quantity returned by color. Starting from our original table, we can extend this further by creating a matrix of color versus product category. This changes the filter context again, because for each data point that is returned, Power BI is applying filter context. For blue socks, a filter is being applied for color being equal to blue and product category being equal to socks. Now that you've understood filter context, let's introduce you to the calculate function. Calculate allows you to evaluate an expression with one or more filter context. The calculate function takes two arguments. One argument is required and the other argument is optional. The first argument contains the expression to be evaluated. This must return a single value. The second argument for adding filters is optional, but you need to ensure that the filters evaluate as a table and do not clash with one another. For example, sales city is equal to London and sales country is not equal to United Kingdom. The filters inside the calculation will always override any filters from a visualization. You can see an example of calculate in action. Here we are calculating total sales in EMEA region. Now that you've seen the difference between row and filter context, let's put into practice what you've learned.
Okay, the importance of context. It says context is important to understand when writing DAX to ensure that your calculations provide the expected results. Additionally, variables and calculate functions are useful for creating complex calculations Let's see if you can differentiate between true and false on this statement about context, variables, and calculates. It says drag and drop the items into the correct buckets based on whether you believe the statement is true or false. Count X is an iterator function. Definitely that's true. Filter context is filter applied after the calculation is carried out. That's true. Row context can apply to calculated columns and measures. Row context is only on calculated column, not measures. There are only two types of context in Power BI, row context and filter context. There's something called query context. She mentioned that earlier. So there's query context. So there are actually three types of context there. Filters are optional in the calculate function. They are not optional, that's false. Is actually compulsory. You have to mention. Ooh, I missed that a lot. Row context can only apply to calculated columns and measures. Calculated columns and measures. Hold up. A filter optional. Hold up, I need to get this straight. Count X is an iterator function. Definitely an iterator function. Row context can only apply to calculated columns and measures. Just a measure. We are writing measures. So you can say calculated column and measure. So I'm trying to get the difference. I understand the difference. I understand what a measure is. It can be very confusing at times. Filters are optional in the calculated function. So the filter part of calculates is optional. Is it that optional? Or the expression? I'm looking at my slide just to on the understanding in. The calculate function says filter filters need to evaluate as a table. So so you need a filter part of the calculate function. It has to be pointing to a table. And it's definitely not optional. I don't believe that. Okay. I'll look at this. Filters always override filters from the visualization. That's true. Okay, this is false. Filter context is filter applied after the calculation is carried out. So filter context will be applied before the calculation is carried out. I understand that. Filter are optional. I'm still trying to find this to comprehend it, but I'm pretty sure it's not optional. Let's see. Row context can apply to calculated columns and measure. Row context is usually applied to calculated columns, but measures. Let's continue first. I'll stock that in so I can actually figure it out later. Let's creating a DAX measure. Let's create our first DAX measure then. Then maybe I'll get all that in my mind. All that locked down. Okay.
In the demo, we'll continue with our commodity dataset. We'll be diving deeper into DAX measures, applying iterators, and learning how to use variables in a calculate function. In the last chapter, we created a calculate column to work out the difference between the opening and closing price. Now we'll create a measure that uses an iterator function to do the same calculation. First, we'll start by creating a new measure called average trade difference and start by typing average, which will use Power BI's IntelliSense to show all the matching functions. We'll select average x from the drop-down list. The average x function. In the demo, we'll continue with our commodity dataset. We'll be diving deeper into DAX measures, applying iterators, and learning how to use variables in a calculate function. In the last chapter, we created a calculate column to work out the difference between the opening and closing price. Now we'll create a measure that uses an iterator function to do the same calculation. First, we'll start by creating a new measure called average trade difference and start by typing average, which will use Power BI's IntelliSense to show all the matching functions. We'll select average x from the drop-down list. The average x function takes two arguments: the table where the aggregation will be applied, in this case commodities. The second argument will be the calculation we are looking to perform on each row. In this case, it will be close subtracted by open. We can now commit this measure by pressing enter. Let's visualize this on a card. We can now see the average daily trade difference of 3.58 across all commodities. Great! Now we've created our first measure using an iterator function. Next, we're going to learn how to use the calculate function. These are one of the most used functions in DAX due to its ability to modify and have priority over the filter context. We'll create a new measure called gold volume 21. For this measure, we want to get the sum of all gold trades that occurred in 2021. In our calculate function, our first argument will be the sum of volume. Now that we've added our expression to be calculated, we can now add the filters we want to apply by using the filter function. The filter function takes a table to be filtered and the specific filter to be applied. Our first filter will be on the table commodities, where symbol is equal to gold. Next, we'll filter the same table again, but this time filtering for the year 2021. For this, we will be using the year function, which we will cover in the next chapter. Great job! Now we can visualize this new measure on a card. We can see the total gold volume for 2021 is 308,000. The final concept we'll be covering is a new topic we haven't covered yet called variables. Variables are very useful when writing DAX calculations. As you write more DAX formulas, you'll see that they can get very complex very quickly. Variables help simplify your code as well as increase readability and performance. Variables can contain static values or snippets of code that may be reusable in your query. To get familiar with variables, we can look at using variables in conjunction with calculate. We've created the measure gold volume 21, but how about if we'd like to see the percentage growth in volume versus 2020? A measure has been created called no variable. Let's take a peek. This shows us a DAX formula that does not utilize variables. If you look closely, you can see that the calculate function is being used twice. This is inefficient for Power BI as it has to evaluate the same expression twice. Let's copy the formula as we'll be using this in our new measure. Let's create a new measure that uses variables called gold 21 versus 20. First, let's create a variable called gold volume 20. Here we can paste the formula we just copied. Now we have a variable that calculates gold volume for 2020. We'll now declare our return statement that will compute our calculation. We will use the divide function to work out the percentage difference. For the numerator, we'll calculate the difference between 2021 versus 2020. So gold volume 21 minus gold volume 20. Next, we'll set the denominator to be gold volume 20. We can now commit this measure and format it as a percentage and round it to 0. Now we can put this into a card visual and see that there was a massive increase of 480% in trades of gold. We've seen variables, iterators, and calculate in action. Now it's your turn. Let's practice.
That's quite a lot to practice. Let's say using variables. So instruction, I want to open the Power BI report using variables. So I've linked the reports, the files below. Let me just open it from my end here. Open it on my local machine so that you can see that better. So the context is, since they started trading, Adventure Works has never increased price even when inflation has risen. The leadership team would like to understand what total sales will look like. Are they taking into consideration inflation when they first started trading? So open the report variable. So let me just open it on my desktop here. You can have it open. So I have it open right here. So report variable. I've also linked that under the description. Do not forget to download that. Okay, let's come back here. That says for this exercise, rename page 1 to variables. I'm going to rename this page 1. Let's rename that to variables. Variables. Okay. Next says create a new measure called total sales with increase that has a variable called increase set to 5%. In your return statement inside the measure, calculate total sales plus 5% increase. Format total sales so that it displays as a dollar with no decimal place. So I want to create a new measure. So let's see, creating measure. So I want to create a new measure called variable. So I have to use the variable function. So I have to rewatch how she created it from the video. Okay. Increased set to 5%, 0.55. In your return statement inside the measure, okay, let's rewatch the video. Let's see the video here.
In the demo, we'll continue with our commodity dataset. We'll be diving deeper into DAX measures, applying iterators, and learning how to use variables in a calculate function. In the last chapter, we created a calculate column to work out the difference between the opening and closing price. Now we'll create a measure that uses an iterator function to do the same calculation. First, we'll start by creating a new measure called average trade difference, and start by typing average, which will use Power BI's IntelliSense to show all the matching functions. We'll select average x from the drop-down list. The average x function takes two arguments: the table where the aggregation will be applied, in this case commodities. The second argument will be the calculation we are looking to perform on each row. In this case, it will be close subtracted by open. We can now commit this measure by pressing enter. Let's visualize this on a card. We can now see the average daily trade difference of 3.58 across all commodities. Great! Now we've created our first measure using an iterator function. Next, we're going to learn how to use the calculate function. These are one of the most used functions in DAX due to its ability to modify and have priority over the filter context. We'll create a new measure called gold volume 21. For this measure, we want to get the sum of all gold trades that occurred in 2021. In our calculate function, our first argument will be the sum of volume. Now that we've added our expression to be calculated, we can now add the filters we want to apply by using the filter function. The filter function takes a table to be filtered and the specific filter to be applied. Our first filter will be on the table commodities, where symbol is equal to gold. Next, we'll filter the same table again, but this time filtering for the year 2021. For this, we will be using the year function, which we will cover in the next chapter. Great job! Now we can visualize this new measure on a card. We can see the total gold volume for 2021 is 308,000. The final concept we'll be covering is a new topic we haven't covered yet called variables. Variables are very useful when writing DAX calculations. As you write more DAX formulas, you'll see that they can get very complex very quickly. Variables help simplify your code as well as increase readability and performance. Variables can contain static values or snippets of code that may be reusable in your query. To get familiar with variables, we can look at using variables in conjunction with calculate. We've created the measure gold volume 21, but how about if we'd like to see the percentage growth in volume versus 2020?
Oh, a minute. Yep, I'm back.
A measure has been created called no variable. Let's take a peek. This shows us a DAX formula that does not utilize variables. If you look closely, you can see that the calculate function is being used twice.
Is it a calculate function twice? That's quite funny. Let's see that in action.
This is inefficient for Power BI as it has to evaluate the same expression twice. Let's copy the formula as we'll be using this in our new measure. Let's create a new measure that uses variables called gold21 versus 20. First, let's create a variable called gold volume 20. Here we can paste the formula we just copied. Now we have a variable that calculates gold volume for 2020. We'll now declare our return statement that will compute our calculation. We will use the divide function to work out the percentage difference. For the numerator, we'll calculate the difference between 2021 versus 2020. So gold volume 21 minus gold volume 20. Next, we'll set the denominator to be gold volume 20. We can now commit this measure.
The calculation is quite funny. Let's check it out one more time.
And format it as a percentage and round it to 0. Now we can put this into a card visual and see that there was a massive increase of 480% in trades of gold. We've seen variables, iterators, and calculate in action. Now it's your turn. Let's practice.
Okay, now let's practice again. It also says create a new measure called total sales with increase that has a variable called increase set to 5%. How are we going to create that variable called increase set to 5%? That's it. Let's give it a shot. So I'm going to calculate a new measure, profit margin ratio. Okay, this was what we created. Sales count. These were simple DAX measures. Let's create a new measure then. No? New one. We have to call it what? Total sales with increase. That is quite funny. Total sales with increase. should now be equal to a variable. What then how do we now set that variable? That is actually set that's a variable called increase set to 5%. So in your return statement inside the measure, calculate total sales plus 5% increase. Ooh, it's trying to make sense. Format total sales with increase so that it displays an okay. It's getting the variable to set. It sets variable that has a variable called increase set to what? 5%, 0.005. So the variable name will be called increase. That's quite funny. I'm going to figure that out. Ooh. Increase set 5%. So I'm taking a peep at the previous results. It says total sales with increase that has a variable called increase set to 5%, which is 0.05. Ooh. Remember, they've not covered the topic variable. And let me even check the argument in the variable. It doesn't have any argument at all. So we want to have the increase. Question: how do we set the increase equals to what? Should we say equals increase set to 0.05? Let's say increase equals to 0.05, and that's funny. Then we close that. Does that make sense? I don't think it makes sense. We are getting an unexpected expression. We are getting an error immediately. Probably says I put my increase. I don't even need to put my increase in quotes. That would be wrong. Cannot find name, so it's you only need to put text. Can see, so it's even telling me that my DAX calculation there is wrong. Now I can't commit that. That is wrong. I need to edit that. And they've not covered variable, so this is quite wrong like this. If not covered the topic, then you're asking someone to create a measure for it. That is totally wrong, DataCamp team. I think I'm trying to figure it out. I should figure it out. So variable increase equals to 0.5%. Then in the calculation, you say in your return statement inside the measure, calculate total sales plus 5% increase. Wow. How do you calculate that? Total sales return. Let's see if it's going to work. Calculate. I have total sales here. Do you have a total sales? Do you have a total sales expression here? I'm trying to figure that out. Even though they've not covered that, I should be able to get it. Total sales plus 5%. Let me see if that makes sense. Total sales in your return statement inside the measure. Calculate total sales plus 5% increase. I think we are going to figure it out. Even though they've not covered that concept, now say return. So this is my variable 0.0 increase equal to 0.05. So it now says return calculate total sales plus, let me see, plus, will it be plus increase? Ooh, plus increase. Yeah, it's starting to make sense. I think that should work. Let me try to cover it. If I try to cover that, will it accept that? Let's see. That's interesting. Let me commit it. If it's not returning any error, that shows my calculation is correct. Wow, I'm good. I figured this out. Like it's kind of we actually set a variable called equals to 0.05 return calculate function. So that means the expression, the filter part of calculate is optional. So you actually use calculate anyhow you want. This is kind of interesting. So let's create a chart for it. I couldn't believe I could figure that out. So format total sales with increase as dollars. We need to format that. Let's format it to be in USD currency. I just have to follow the instruction. So it now says in the report view, create a card visual. Create two card visual that show total sales and with increase. So let's go back to the report view here. Just drop a card visual. There's a card. You can just drop total sales in this one. This our total sales is 29 million without increase. That's 29 million. My total sale with increase, it says with no decimal places, so we got that. So now drop another card. Then this card will now have, so I just launched a new calculation, 29.336 million. So it's an increase, total sales with increase. So ordinary total sales here. Wow, that calculation was quite simple and straightforward. So we've actually created from previous live stream, we've created the total sales, total profits, sales count, profit margin ratio from previous live stream. So our results, our answer here should be 29.29. Ooh, with the 5% increase applied. Oh, I didn't get it though. Wow. So it's 176 million, 31 million, 44 million. Oh, I didn't get. Let me take some ints first. Ints. Oh, look at my calculation here. So I actually got the formula. If you calculate the new total sale with increase correctly, your formula should look like this. So variable increase, I got the variable part. The return part was saying, oh, my mistake was calculation, return calculations, total sales. Oh, I failed this part. I was almost happy I got it though. Calculation total. Okay, I got the part. It should be times increase. So if I think with increase, it either has to be the total sales plus total sales times increase. That's quite funny. Let me just go back here. Rather than saying plus increase, should it not be plus increase first? Let's see. Instead of saying times here, I want to multiply it first and see if it's going to change. It changed to 1.4 million, but the calculation says it has to be total sales plus total sales times increase. That's quite funny. Return calculation. If you look at the context here, it says total sales with increase in variable code increase set to 5%. In your return statement inside the measure, calculate total sales plus 5% increase. So if you don't actually understand how to use variable, oh, that's quite interesting. So let me just look at this. It's a return calculations. Is it calculation or calculates? So declare a variable using var called increase and set it to 5%. The first part of the formula, it will look like this: variable increase 35%. In the return function, your calculation should look like this: return calculation total sales plus calculation. To format total sales, select, but I don't know the part calculation. It's not supposed to be calculate, not calculation. It's saying, is it calculate? Is there any formula called calculation? I'm coming. Calculation. Yes, there's nothing called calculation. So it's supposed to be calculates. Let me just start again. Calculate to be total sales plus calculates total sales also. Now be times increase. Then they need to still explain how that came about. You can see it's not saying 30.83 million. So but you need to understand how. So if you want to, this is the total sales without increase, which is 29 million. The total sales with increase of 5%. So it's an increase of 5%. So sometimes it could be hard figuring out how to do some calculations in Power BI. If you want to increase something by 10%, I remember when I was doing some calculation in Power BI one time. If you want to increase a total by 10%, it has to be 110%. So I'm going to calculate the 100% plus 10%. I think I'll use that knowledge. I'll look for that. So it should be 30.83 million. Oh, that's like 31 million. Let's see here. You can see a 2 million increase. 31 million. But getting that calculation or actually understanding the return part could be very tricky at times. Let's continue. So iterator functions. So let me just save this. It's something that I always have to come back to. These calculations can be quite funny at times. So doing it now will actually make me to remember it pretty well, and I need to do some calculation like that also. So iterator function are very useful for running calculation without the need to create calculated columns. So in this exercise, we will be comparing the output of average versus average X. Okay. Oh, we're almost through with this lesson here. That's interesting. I learned how to calculate something new today with a percentage increase in calculation. That's quite funny though. So let me open the new exercise file, which is iterator functions. That is 2.2. Don't forget to download all the files so you can practice along with me. So the best option is to practice and practice. Don't just watch it like a movie. It now says add a new page called average profits. So create a new measure, average profit, which calculates the average of all profits. This is still coming up. Then after that, create a new measure called average profit X that uses the average X function to subtract line cost from the price. Format average profit X so that it displays as a currency with no decimal points. Then create a clustered column chart that shows average profits and average profit X. Then we need to answer, is the output of average profit X and average profit the same? It definitely won't be the same, but it should be the same. Let's hold on. Okay, so this has come up. Oh, the calculation is even here. I definitely know. Oh, they use something different to get the exact 31 million. So when I look at the file here, equals to calculations, then they are pointing straight to the DAX table. That's interesting. That's another thing I've learned there. But let's continue first. I'll jump back to that later and compare it. So add a new page called average profits. So we want to create a new page here called average profits. Average profits. The new page is called average profits. Okay. So create a new measure which calculate the average of all profits. Okay, that is quite simple. A new measure that should be called AVG profits equals to my calculation is not yet correct. AVG profit equals to average of all profits. We have a profits column here. Or probably average of total profits. Average of what we calculate average of all profits. Let me see. Is there a profits column there? There's a profits. Yeah. There's a profits column there. That should work. So the next one says create a new measure called average profit X that uses average X function to subtract line cost from price. Okay. Line cost from price. That is price minus line costs. That should be a new measure. So we have this average profit. Then we create a new measure called average profit underscore X. Then we use average X this time around. So the table will be our sales table. Then we are going to iterate on the average. Oops, wrong slide. Wrong browser. We subtract line cost from line price. That should be line price. The line price column, which is this one, minus line cost. So if you don't know understand how iterator function works, maybe we'll get okay, that should be correct. That should give us the average also. Then the instruction says format average profit X so that it displays as a currency with no decimal. So we need to format average profit X. It displays as a currency with no decimal. Okay. We are getting there. So we're going to create a clustered column chart that shows average profit and average profit X. A clustered column chart. If you drop a clustered bar chart, this is a clustered bar, this is a clustered column. Then we are going to drop average profits in it, then average profit X. They're not showing same, they're definitely going to show same results. So it's showing 2200.02. So it's showing 200.02. They're showing same thing because it's the same calculation. I knew they'll show same thing already. I knew it, so I just wanted to make sure that is correct. Oh, our final calculations there. So sales by category and year. So in the previous exercise, you calculated revenue by using a sum functions to the total line profit column. Now you need to calculate the total sales and filter by category, bikes and other year. That means we want to use the calculate function. So in this exercise, we'll be utilizing the calculate function. I think the new calculation I learned in this lesson is the variable function and how to calculate 10% increase in total sales. I need to look at that one more time and make it stick. So we're going to open a new file called calculate.powerbix. Let me just close this file real quick. Let me close this calculation. Then I open another file called calculate. That is 2.3. Don't forget, you can have access to the files by clicking the link in the YouTube description, so you can practice all these calculations also. Also, the answers are there in case you couldn't figure it out, but make sure you understand how the calculations are working. So the instruction says for this exercise, create a new page in the report called sales. Oh, it's still coming up. I think it's up. Yes, we want to create a new page. So we have variable calculation earlier from earlier, average profit calculated earlier, then a new page called sales. We're just calculating simple calculations currently without going to add. So create a new measure called 2018 bikes revenue. So I want to calculate uh, the sales for bikes in the year 2018. So we're going to use calculate function to do that. So the instruction says create a new measure called 2019 bikes revenue. So just create a new measure and call it 2018 bike revenue, which should be equal to calculate. And this is definitely going to be calculate. So we are going to the sales table, definitely the sales table. The expression should be total sales, definitely total sales. It says which calculate the sum of line price and filter on the product category price. Which calculate the sum of line price. You say the sum of line price. I don't even need to put sum there. I can also calculate like that. You can calculate your measure, even though you don't want to use a measure earlier. I can use the sum function, then I'll point to the line price column. So it's going to sum the line price column. All I need to do is to close that sum function. That's my expression. So I know calculate can work like that. Then my filtering criteria will now be on which will filter on the product category bikes. So it's now filter product category. Let me see. I think we have a product category there. Product category equals to bike to bike. So let me just bring this, shift enter. So product category equals to bike. That's our first filtering criteria. Then come another filtering criteria now be the year column. Then and year, that is order dates, is 2018. And now the year function to filter on the order dates. Order dates equals, so the year is going to extract that for me exactly. So I need to close that. I'll now point to year equal to 2018. Then that should work fine. Then all I have to do is just close our. We really need to close it with one bracket. Yeah, let's check that. That should be correct. I think we know that real quick there. Do I need to format it? Create a card visual that shows your new measure. So the calculation, let's visualize the calculation with a card visual, since we actually calculated for the 2018 bike sales blank. Why is it showing blank? Oh, probably I've not formatted it correctly. Let's format it as currency and see if it's going to change. Oh, it's still showing blank. Am I missing something? Definitely not. Let's see. How much revenue did bike generate in 2018? Format as x.xsm. Mine is showing blank, and I'm pretty sure my calculation is correct. Sales sum, sales line price. Let me go back to the instructions. It says create a new measure. Okay, yeah. The sum of line price, the sum of the line price column, and filtered on the product category bikes. Let me leave it as blank. So I'm missing something. I'm missing something. Where my 2018 bike sales telling me it is blank. calculate some sales line price where the product category is equal to bike. What am I missing? I'm missing something. Oh, this is the last part, and it is getting filtered on the product category. Bikes. Okay, this is bikes. Wait a minute. I'm writing bike. Look at my mistake there. Definitely, there's nothing called bike in the O. Oh, you see? So I was making a mistake in my product category. I didn't spell bikes in the record. If you go to the data view, if I go to the product category, you can see that I have to be pretty sure you understand your data sets. You can see, let's product category. If I check, we have accessory. You can see it is spelled as bikes. And I was spelling my own as bike. That's why I was having that blank calculation. Bike instead of bikes. Imagine something as simple as that. That is 6.3 million, 37 million. That is 6.37, if I'm correct. 37 M. Ooh, imagine we got that. That was a silly mistake there. It's quite interesting doing some calculation on this live stream. Right. Because hey. So we're on the last chapter, which is working with dates. I think one of the things we must know very, very well as a data analyst is actually knowing how to work with dates. So I'm going to stop. I'm going to stop here and we continue on day 7 of the live stream. Do not forget to practice along with me also while watching the recordings. You download the data set using the link in the description so you can practice and learn also. Alright, so thanks for staying to the end of the live stream. So if you found value in this video, do give this video a thumbs up, subscribe to the channel, and put on the notification bell so you'll be the first one when I drop a new content or when I go live on the channel. Welcome to the journey of a data analyst, and I'll see you on day 7.